topics covered in areas related to CBSE. Welcome, everyone. Today, we are diving into the topic of areas related to circles. Now, you are likely already comfortable with calculating the basic circumference and the total area of a circle, but this chapter moves far beyond those fundamentals. We will be exploring the fractional parts of a circle, specifically, how central angles and chords divide a circular plane into distinct, measurable regions. By mastering the relationship between the central angle, the radius, and these resulting areas, you will gain the precision needed to analyze much more complex geometric figures. To guide our study, we have 4 primary learning objectives. First, we will learn how to calculate arc length, which is the distance along a portion of the circumference. Second, we will explore the area of a sector, that is, the region bounded by 2 radii and an arc. Third, we will tackle the area of a segment, which is the region between a chord and an arc. Here, you will learn the method to derive this area by subtracting the area of a triangle from the area of a sector. Finally, we will apply all these concepts to solve problems involving combined figures, such as those involving semicircles and polygons. As we move through this lesson, keep in mind that these are not just abstract formulas. In our next slide, we will see how these very principles are applied in real-world fields like engineering, architecture, and even astronomy. Real-world applications of areas related to CBSE. Now that we have established the fundamental definitions of arc length, sectors, and segments, you might be wondering how these geometric principles apply outside of a textbook. The truth is, the ability to calculate these specific areas is vital across many professional and scientific disciplines. For instance, in architecture and civil engineering, these calculations are essential when designing structural elements like arched windows, domes, or even tunnels. Similarly, in mechanical engineering, the precise design of gears, pulleys, and cams relies heavily on understanding circular sectors to ensure smooth and efficient mechanical motion. We also see these principles in urban planning, specifically when designing roundabouts, circular parks, or various zoning areas within a city. Even in the vast fields of astronomy and physics, these concepts are used to calculate the visible portion of a planet or moon during an eclipse, or to analyze the trajectories of satellites in circular orbits. Finally, in manufacturing, the precision required to cut circular metal plates or produce automotive tires depends on these very same mathematical tools to ensure material efficiency. As we move into our next lesson, keep these real-world applications in mind, as they demonstrate the true importance of the precision we are about to study.